All right. It is. We are live. Hello, Ben.
We
How
are.
are
Hey,
you?
Bill. It's great to see you again.
Yes. We've been
Great to see you.
chatting here. Ben was talking about his 3D printer. And the thing I was going to add is I never got my 3D prints to ever print completely without a problem. So for the few that I did, I would send out to him to a print house.
It was that way. I remember. Um, let's see, when 2015 or 2016, we needed some custom enclosures 3D printed for a reference design for the release of Circuit Maker when I was at Altia.
Right.
We wanted to do a little reference project to show off design reuse and like building block based design as a platform. Right. That eventually led to them acquiring Geppetto or Gumsticks, which had Geppetto, and then smooshing that misfitted puzzle piece into what was once upon a time Upverter.
Yeah.
And then just calling it Upverter. It's not a PCB design tool anymore. I'm going round and round on this story, but that I remember back then we paid hundreds and hundreds of dollars to have a local print farm,
Right.
which I think there's still good money in that as a business model. There's people who don't want to own a 3D printer or don't have room for it, and they'd rather just have someone else print it, and because if until you understand it, unless you can spend the money on a decent one.
Right. And I got into it too early with not a great one. And
so the 3D printers that were $300 or $600 in 2015 were still really rough.
Yeah.
And
you had to do so much to it yourself to try and
tweak and the slicing algorithms were rough.
Yeah.
But I just got a $500 printer basically given to me by a customer because they needed help with something, and they said, yeah, we'll get that to you. And it was kind of a bonus that's like it can be yours, and anytime you need to print some custom mechanical board standoff or piece or anything for doing our research, it's just right there. And I bought tons of filament, and it's just a Creality Ender 3S1. It's not a particularly high-end one. It's very affordable, and it does amazing.
Cool.
It does, like, I'm seriously, one of the first things I printed other than the test print, I got at the advice of my friend Mark Harris, who some of you probably have seen him online, and he does a lot of content for Altium these days too. I got PETG filament, and I realized this is clear, and I can make custom LED rings for foot switches for my my guitar MIDI foot controller design.
So that fits around the momentary switch or the foot switch. Yeah, very cool.
And there's going to be, and this I haven't seen on any commercial foot controllers yet, but I've designed a circuit board to go in there. It's going to have NeoPixels, so I can animate them even instead of just pick one color. I can make it do things like rotate or change color, whatever, anything I want. So it's another complex project that's I probably shouldn't have started because it'll take too much time and I don't have the time, but
but
so yeah, I mean, it's enabled so many things to move forward that were stuck in my head because I thought I'd do milling, metal work, hand cutting and filing stuff, and it's error prone and frustrating and too time consuming. So I've been doing this. I'll see if I can pick this up without dropping it all. It's like a old school show and tell today. This is the inside of an amplifier build I'm working on for my studio monitors.
Okay.
And I didn't design the actual amp modules. I'm just using AEMA ones that are very popular. You see them all over AliExpress. They're really cheap, and they're actually, you can get them as kits or fully assembled. There's a switching power supply specifically designed for audio power amps with a plus and minus 45 volt regulated output and 500 watts. So I can
Do
put
they use a frequency that's more compatible with audio for their switching frequency?
Judging by the size of the transformer in this, I would say it's probably
in the kilohertz.
Some of the better ones are resonant converters,
right?
And so they have less EMI and other things, but this is probably running at 200 kilohertz.
Right.
It just judging by the size of the transformer and knowing that it's 500 watts rated. Apparently, I haven't measured it to check. They could be lying. You know how it is.
Right. Right.
The cool thing is it's got post regulation using linear regulators. So 7815 and 7915 for powering op amps in any preamp circuitry or other control circuitry I might have around it. So that's cool. And yeah, I'm going to document all this and make a video series on it because it's coming together so nicely. But I designed this whole cooling scheme. All the modules just came from AliExpress. These heat sinks came from AliExpress. So I designed all this in Fusion 360 to go together. And just once, as soon as I had the 3D printer, I realized, wow, I can make this a full-on, like, professional grade.
Yeah.
Amp in a 2RU case. And I still have to design the I/O, like the front and back panel controls and jacks and all of that. I'm going to design boards for those because I wanted to not just have a basic setup with inputs and outputs and a power amp. I'm going to use 4 modules, which can be bridged. So I'm going to have bridging circuitry in there for channels 1 and 2 and 3 and 4, and maybe even put in a crossover network so I could have channels 1 and 2 be just the 100 watt modules for full range, and then channels 3 and 4 bridged for sub. And yeah, I've got the nice Noctua fan, low noise fan in there. So 3D, and this is all 3D printed, just using the design straight into Cura, slicing it and orienting it on the bed such that it's pretty accurate.
Right.
No real supports needed. Like, it just does a great job. And you can see I did the design of this to even out the ducting. So it's going to suck air in. It's going to suck air in from the vents on the bottom of the chassis, blow it through across the heatsink and out the top. And I even have a little thermocouple there on the fan control module. Also, I got this fan control module. These are all over Amazon. They're pretty common, and you can program them. They're kind of difficult to program because they have a single button user interface with 3 LEDs. I'll work it out when the time comes, but I'll tape that with some heatsink compound to the top center of the 2 heat sinks with some Kapton tape. And
are you going to put a filter in it? You'll be picking up dust from the bottom, right?
Yeah. So I'm gonna cut out some filter. I don't know what I use. Probably the same sort of filter paper that they put in household filters for your HVAC system, your ducted air conditioning or whatever.
Right.
I'll find something like that and cut a little square and put it in the in that intake duct.
Open cell neoprene.
Open cell neoprene. There you go. So you know all the terms for all the stuff.
So hey, I have some news. So VCF is coming April 14th, 15th, and 16th. And they've moved my thing to Saturday. We started getting a lot of people. So we'll be talking about video streaming, and we've got David Murray showing up from 8-Bit Guy. We got Usagi Electric, and Adrian Black who's been on before, Adrian's Basement.
Yes.
And Jerry Ellsworth hasn't said no yet, so it's one
of those. It would be great.
We don't know till we know.
She might want to do one of those surprise celebrity appearance type things.
Right.
I've seen her do that before years ago at Maker Faire. She just showed up in a pair of roller skates. No one knew, but she was
She's
one of the most
we
friendly,
talked about her roller
approachable.
skates. Yeah,
She's one of the most friendly, approachable people I've ever
Yeah.
met. I would say she's
Yeah.
super cool. Anyway, yeah. So what's been what? Hey,
So
someone mentioned news this week. I think most people watching would know. KiCad 7 came out. I haven't had a look at it yet. Have you, Bill?
No, and I did some designs this week, and I was tempted to try KiCad 7 because I was starting from scratch, but I grabbed my Altium and I fastballed it. I actually was placing parts. Usually when I go to the manufacturer panel and you bring up the part you want, and one of the options is place, I never do that. I download it and I meticulously put it into my file-based library.
Absolutely.
But for this,
Me
I
too.
place, and then just made a schematic and PCB library for the project afterwards, so that I still had a copy.
Sometimes when I'm in a rush, I'll just go and trust the parts from that used to be called the Altium Vault server.
Yeah.
And what I found is they used to have this feature, and I don't know if it's still there. I need to look into that actually, and if it is, show people, because it's kind of a hidden gem. But I suspect they took it out because nobody used it and nobody knew about it. But there was a way. There was the product architect who was at Altium years ago, Mark Dupre, built this thing, and his team built this thing where if you were acquiring or copying a part out of Altium's Vault, which now is just the manufacturer part search panel, right, into your own, you could have it automatically map the layers, and even in the schematic symbol, you could even have it change the colors of lines and fonts and things.
Like the scripting language?
It wasn't. It was, you'd have it. And the reason nobody used it, because it was in its infancy as a feature, and you had to create XML files that defined the mapping, and the colors, and but what it meant was anytime you did an acquisition of a part from the cloud to your own server, your own library, it would automatically remap things. It would put the 3D body, instead of just going default to mechanical 1, it would put it on your layer that was designated ahead of time for 3D bodies. And so it would save you a lot of that cleanup time. And I did a video on it in 2012, like years ago. And I think the video has probably been taken down off of, when I left Altium and went to Autodesk, guess what they did? They basically
purged you.
Tried to remove me because I was everywhere on their site.
Yeah, you were.
YouTube channel. They tried to, which is understandable, I guess, because they saw Autodesk as a competitor, even though they're not really. But yeah, it's history. Let bygones be bygones. So I'm going to try and find that. Actually, that's a mission for this week, because I've spent hours and hours and hours and hours and hours trying to refactor parts that I've downloaded into my own layer organization, particularly in the PCB footprint side. I like, and any good hardware designer will do this, hardware engineer will do this. You want to be meticulous about where things are at, because it actually saves time on the back end when you do product documentation, to have everything in the right place. Right. Anyway.
Well, the thing that I would not have known about Altium if you hadn't shown me was unlocking the primitives in the PCB editor, so that I could move that stupid pin 1 dot that's never in the right place. I was going back and I was adjusting the symbol in the library. Yeah. To move it to an innocuous place.
Good PCB tools are they're kind of like the C programming language. You can shoot yourself in the foot, but sometimes you need that level of flexibility to be able to change things when you're in a bind and you've got no time, and you don't want to spend 2 hours rebuilding a part in a library perfectly. You'd rather just quickly modify it right there on the board.
Right.
But if you're willing to take the risks associated with that, you can do that, right?
Yeah. Well, it's funny with Audium, when I'm first starting a project, I'm like, and it blows up, craps out, or I do something wrong, I'm like, oh yeah. But if I'm near the last 2 weeks, I'm like, it's changed. Don't anybody breathe. Okay. So I'm so afraid of doing something systematically wrong that I tend to lean on the back end, if that makes sense. So,
yeah.
So I had somebody go to the Herdware website last week, and ask about thermocouples, which I had done a thing on Hackaday about. And then I had a little, here's one here. I was selling these little thermocouple amplifiers off herdware.com. And this gentleman called, and he's doing a furnace. And I thought he meant a furnace for a building.
Like industrial or HVAC.
Melting furnace or something, because it's thousands of degrees.
Wow.
And it's Type C thermocouple, which I had never heard of. And he wanted a circuit, and I'm like, wow, we need real small voltage care, microvolts, till I realized that 1,000 times a microvolt is millivolts, right? So this thing is dealing with almost handleable voltages because it's so damn hot. So what I did is, I'm big about housings, right?
Yeah.
What are you going to put the project in? And again, I thought it'd be a dusty environment. It's more like a tabletop, but I'd already
you want something industrial, sealed. It's probably got neoprene seal around the.
It's got a neoprene seal around it. Yes,
I love those. Yeah.
Yep. So, but what I did was I bought a backing plate that fits inside it. So, but
Hammond, that's Hammond. I love Hammond manufacturing.
Hammond MFG is the website, and Pactec, PACTEC, is also the other place I check.
That would be a mission of mine, I think, to get my Guitari Guru channel to a place where maybe one day Hammond will want to do a brand deal with me. That would be cool.
There you go.
A guy can dream, all right? Hammond is awesome. They also make replacement tube output transformers and all sorts of stuff for the musical instrument business as well. So anyway,
so here's what I did is I took the file off of Hammond for the backing plate.
Yeah.
And I read it into my Audium and made because I am very poor at mechanic stuff. So I made a PCB that's got arcs and everything like that I expect to fit when the time comes.
That's cool. Did you, was it the DXF? Because I know the Hammond
DXF
MFG
had problems. It was not bringing in the holes. And I ended up trying it again with the 3D body, which I never knew about.
They'll give you both. They'll let you download just a 2D DXF
and a step.
IGES or step. Yeah.
Right.
So.
Yeah, and it sure beats the old days where you sat there and you looked at dimensions and everything, trying to get that right.
Oh, totally.
So this is
what you might want to do though. Well, what you might want to do is open the DXF or open the step in a 3D mechanical tool first, and then
isolate.
You don't want the board to be the exact same shape as the base plate.
Well, that's why I use the plate, right? Because the plate's already got tolerances for fitting.
So it's already shrunk down. Yeah. Yes. Okay. So in other instances, I'll bring in the actual enclosure and I'll pick the face, but then
that's what I
do an offset.
Yeah.
Do an offset inwards to make a little bit more of a clearance.
Right.
Yeah.
Right. Very cool. So I did a fast turn to JL, one of those. 2 hours later, I'm sending the file to. I buzzed through.
That was quick.
Yeah,
it's a big enclosure for a little circuit.
It is. I was mostly worried about
plenty of room for feature creep on the product.
Well, that and for the bushing itself, if I go to a Liquid Tight, are you familiar with Liquid Tight?
No.
You probably are. Here's a Heiko. You've seen these. I used to use these back in the days of steam washdown and stuff.
Oh, those
Compression
bushings.
Yes. Yeah. So
that does that have a soft as a piece of neoprene or soft rubber inside?
These don't. These just deform to the plastic deforms to it by tightening it. But I've seen them with those. Problems with gaskets is they fatigue. You know.
Yeah.
So, but anyways, if you're going to mount that, you need clearances, and then to hand wire it to the terminal stuff. So I gave myself lots of room for that tiny little circuit. Yeah. So that was, but in hindsight, I wished I picked something smaller, but I already had one of these around. So I tend to like pick something I already know too. So that was one little circuit this week. The other thing that I've been playing with is this.
Oh, you got a Neo.
I did. I got a Neo because I needed to program this. Let's see if I can get it to focus. Hang on.
Yeah. What? So you're using a Neo? You're just using the ST Link on the Neo.
I'm using I2C.
Oh, so what's the little board?
So the little board is a USB-C. Let me see if I can get it to focus. Let me get.
So this, folks, this I guess ties into our discussion last week. If you went, go back and watch it because we're discussing the footprints and all the mechanical challenges of working with USB-C.
Right. So
what is? Yeah.
So USB-C has a power negotiation (PD), right?
Okay.
And this little board has a ST-USB 4500 chip on it. The eval board, I pasted a link at the beginning of the chat for this eval board.
Right. I think we looked at that on the website last week. Is that right?
We may have. So I bought one.
Yeah. So you got so you can learn how. So that chip does the negotiation of, hey, I need 100 watts. And the host says, I can't give you 100 watts. And so it says, well, I'll take 25.
What can you? Right. Exactly. Exactly. And hang on. I want to show the screen of the programmer here. Here we go.
Oh, yes. I think someone was asking for a link in the chat. Oh, saying you linked in the Discord chat. That's right. You did. That's right. That's where I saw it. You put a link in the Discord chat. So if you're not on our Discord,
Right.
go to Coriolis-effect.com and there's an invitation to join it at the top there. I'll just put a banner up so you can see it.
Cool.
And it was either in the announcements or the general thread. I forget which one. And you put a link to this board.
We accidentally chatted in the announcements channel. That was my fault. But so here. I finally got this working. The key, Mike Fikes knows this because I was grumbling yesterday, trying to get I2C to work between these two. And so I even got on there with my digital discovery and was debugging I2C. Well, because I was afraid of the 20-volt possibility, I hadn't plugged in the actual module. Well, it needed power, so I troubleshoot. This had power, but not this, and that was kind of bonky. But I got the software to work, and what's interesting is I can plug this in. I went and I got a power brick. Hang on. I went to DigiKey. And very carefully picked a power brick that said, yes, I can do 15. Yes, I can do 20. Yes, I can do 9. And it's a USB-C output. So what I did right before we started the show was I plugged all this in. Oh, and one other little cutesy thing. Get yourself one of these. For playing with USB is what I do. Let's see.
Oh, is that like a USB analyzer in a little?
Yeah, cool. And it's got USB-C on the sides, which I didn't know till I saw somebody else using one.
That is cool. I've seen those. I haven't had the need yet, but
right. But it's a way to break into USB without tearing open the cable and clipping, stripping
Yes,
the wires in the
much
center.
better.
Yeah. So what I did was I plugged it in, and after I got everything working, and sure enough, it negotiated this 20 volts right here. Right? That's cool. It's like ding, 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 because that, as you said, it's like, well, give me the best one you can. So what I did is I went in and said, well, what about 18 volts? Right? Because I'm thinking, oh, are you a variable power supply? And the brick said, no, but I'll give you 15. The voltage dropped to 15. It was pretty cool. So because it failed, so these bricks have, or power sources or whatnot, have ranges of voltage, but they also have different values in between that you can, some do 3.3, some do 9.
So now that you've been playing with this negotiation controller, question: is it only for the load device, or can it also be for the host? Can it do both sides of the negotiation?
No,
so this chip would go in a power supply or charger.
This is upward facing port, and it's a sink. It sinks voltage. You can obviously USB-C itself can be set up to be charged or discharged on a laptop. Yeah.
Yeah, that's the beauty of it. When I first heard about USB Type-C when it was brand new, and the one thing about it that was just awesome to me was that it was 4-quadrant.
Yeah.
Basically. Well, it was, bidirectional power delivery.
Go in and out, right? Like my cool power supply back there that my Keithley. I'm renting. That project's coming to an end. I'm going to have to send it back, and I'm going to miss it. It's my 2281S, and it's cool. You plug into it, and you can see it when it kicks. When my circuit kicks into battery charge mode, you can see current going back into my supply. It's pretty cool. So, anyways, this was, and I've been thinking about maybe doing a Hackaday video on USB-C if I can find enough of these little things to expose. Like, I was afraid of the power negotiation. I didn't know what it was because I hadn't researched it, and so this USB-C thing is like, okay, it's time to learn USB-C. Yeah. Well,
and then of course, naturally, the next thing we need to work on with that are there libraries we can easily use that work with that chip? So the evaluation boards are cool, but they've always developed like a Windows program that you talk to it over a USB. You talk to it over a UART, USB UART thing, and it configures the chip and shows you all the stuff. But it's like, okay, that's cool, but now the software library, we want a driver that'll work, that we can include in any microcontroller project.
Yeah, it's a simple memory map. I'm actually looking for it here, and it's I don't have it handy. I suspect that it's going to be write your own for a few years.
I love that, Mike. Get off my RS-232 lawn. Yeah.
Well, so yeah, Mike was talking about an I2C aardvark. Till I got this actually working by plugging it in, I was like, all right, I'll get an aardvark. I'll do my own. I'll register map it. I'll learn all the registers and stuff, and then it started working. I was like, so that's
okay. So I'm going to expose myself and be vulnerable. What is a USB aardvark? Was that the little board with the TFT, tiny TFT on it, or that's something else again?
The way Mike described it, it was, I assumed it was USB, but it was a USB to I2C converter, basically. But
okay.
But I don't think it looked like a COM port. In other words, I don't know that you could use Python with it, for example. Mike showed me that he was sending commands from inside a window in it. So it was kind of a...
That's too much, Chris. V35. Now you're going way back. You remember V35 packet switch networks? This is before Ethernet, pretty much. Well, it kind of overlapped, but V35 is what telcos used for digital voice communications from the 70s, basically. Oh, well, look at that.
That's
Look
for
at that.
a Cisco. That's a V35 connector for a Cisco. I believe that's
Crazy.
a V35. Yeah, I tried to sell it on eBay about 15 years ago, and it was already obsolete by then.
Yep. Maybe sell it now, though, because someone's probably restoring some ancient V35 mini computer.
Right.
Yeah. Hey,
oh, that's so
if anyone has that audience, it's you, right?
I was going to say, stuff we wouldn't touch 10 years ago is now like, oh, I restored a PS2. And I was like, oh, my God, I've thrown so many away, you know?
Yeah.
Cool.
Yeah, my first PC was a PS2 clone by Memorex Telex. It was a 286, and it had a 20 megabyte hard disk that was SCSI that had stiction. And half the time when I tried to boot up to get it going and do my college homework assignments, I had to I'd pull the case off and whack the hard disk with a flat hand, like bam, and it would spin up. And then I'd leave it running because it's like, I don't want to have to go through.
So you didn't whack it while it was spinning?
No, just when I first turned the machine on, if it wouldn't spin, I'd whack it. Wow. And it would start spinning. Yeah.
I wonder, was it a synchronous motor and just stuck between poles?
No, these at the time, these ended up having a reputation for this. It was a particular Quantum SCSI hard disk drive model.
Yeah.
And it was just the bearings had some kind of
high coefficient of friction while it rests.
They had some kind of cut rate lubricant that didn't do its job properly.
Right.
So, yeah.
Well, that's a problem with turning off a disk drive that's been on for years, right? Is you turn it off and that lubricant might harden.
Yes.
The drive's never coming back on, you know?
Yeah.
So, and yeah, I've seen that. But that was back in the days of the full height. Remember full height drives for PC?
Oh, yeah. 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 Were they called MBM drives?
MFM?
MFM, that's it. MFM. In those, yeah. 2860.
Yeah.
Yeah. So, yeah. Cool. So what's next?
Yeah, that was kind of what I worked on this week. Oh, what was the other thing I did? Oh, Mike and I were playing, Mike Fikes, one of our followers. We were playing Resolution last night, which is, what's the resolution on your DC bomb? You know, so I think he won, but I have an old Keithley. What is this model? A 195A. And I had a cabling issue, and I'm thinking, oh my God, my 195A is on the way out the door because I had a lot of noise in the last digits. And I'm hitting filter, built-in filter, and the Keithleys love them. It's a 20-year-old. But
right, you still have needle-based old needle meter somewhere, right? An old needle vom.
I have a Simpson from my childhood.
Yeah, that one. That's the one. I think you've shown that. So those, my first electrotechnology class in college, they had one of the labs had those were still the main instrument for that lab.
Right. Yeah.
And the whole semester we only used those for this was the first electrotechnology class where you're just learning what a resistor is, what a capacitor is.
Right.
What power is, just all the basics. And it's like, come on, guys, I've known this stuff since I was 8 or 9 years old. And I aced the class. But one thing that I did learn in that class, that we also did our first introduction to oscilloscope practice.
Right.
And I had my own oscilloscope also at home by then, an old tube oscilloscope my brother gave me. And so I'd already used them a little bit, but I learned how to get the maximum resolution. out of instruments, analog oscilloscope and the VOM. And those VOMs were awesome because I love the little mirror under the needle.
Right.
So you can you
Right.
close one
Parallax.
eye,
Yeah.
and you remove any parallax error.
Yep.
So you're not looking at it sideways, you're looking at it dead on, and your limit of reading is half of a division because you can see you can normalize if the needle is close to the center or a bit past center or a bit, so they were great.
Right.
But it's like, this is where you want some of that old gear is actually kind of still has a niche in need, because you can do things with that a needle will normalize things it's hard to do in software, right?
Right.
So anyway,
here's a website I used while Mike and I were talking, because then we got to talking about arbitrary waveform generators. And so I was looking at a Siglent that's 14 bits, and I'm like, well, wait a minute. I'm old school, right? So I like to put, what does that mean, 14 bits?
Yeah.
And there's a
formula. And how many of those bits are actually
usable?
Error.
Right. So hang on a second. Share screen. Window.
I'm half distracted, people, because I'm installing KiCad 7 while we're talking. In case I also want to get vulnerable and poke around with it live, because I'm not a KiCad user. I am also like Bill. I use Altium. For some hobby projects, I still have them up in Circuit Maker. But I do use KiCad in that if I want to do something with open source, the sources are almost always going to be a KiCad project. So I'll open it and poke around there. But yeah, so
14 bits turns out to be 86 dB signal to noise ratio,
which is actually pretty good.
But that's near where you can hear it, right? 70s is kind of audible.
Well, and that's the thing. This is something about when I first learned digital audio too. If you're talking audio, right?
Well, I'm converting the audio for purposes of understanding what 14 bits is.
Yes, but what you see on a scope screen, you do realize that most oscilloscopes are still only 8-bit.
Right. Yeah.
The really expensive or higher end ones are 12 maybe.
Right.
And if I think there are some which are 14. And Redbook Audio is 16. Because that's where we need to be to get the noise floor. If you have a perfectly silent track,
right,
playing through a really high quality low noise amplifier and speaker set,
right,
where the hiss becomes imperceptible from randomness, it has to be lower than that LSB of 16 bits. But the actual encoding on the disc is 14 with some kind of special encoding. I've forgotten now how they do it, but the actual encoding on the CD is 14 from my recollection. I could be wrong, but this is what I recall, and they've companded it somehow to get those extra 2 bits. So by the time it comes out, it's 16 bits. But yeah, I record 24 bits.
So
when I'm trying to make
which is just,
music.
We say, ooh, 24 bits, my music of the iCore. What's it? Something of the MOI. What's that creature with the horn on its head? Unicorn. Yes. So they're the unicorn stuff is like 24 bits and stuff. It's just insane. It's 146 dB down, right? You don't need 24.
You'll never actually get that, because
that's right too. Also,
I'll tell you what, the metal film resistors and connectors will add more noise.
Right. Exactly my point. So once you get above a certain amount, and I call it around 100 dB, 90 dB signal to noise, I can't hear the difference because there's all the other noises in there.
We record 24 bits in multi-track audio because when you're mixing multiple tracks digitally,
you don't want
you don't want them to interact with each other and add noise artifacts in the mixing process on your computer. So you capture as best as you can, and then when you mix a lot of tracks together, you're not adding any perceptible noise. That's why we do it.
Right.
And then when you listen to it after it's been mastered, then it's like, well, 146, you're not actually getting that. You're getting flagship, high-end, expensive codecs will get about 110 now. Or in between 100 and 110 is about as good as you can get with the analog stuff around it. So yeah, it's but for measurement and test. Did you go silent? Or were you just not talking?
No, go ahead. No, I was doing calculations here on the screen.
6 dB SNR per bit.
It's a good assumption. It's part of the formula. If I don't see where the formula is right now.
Let me get Rabina and Schaefer's classic novel on signal processing out.
So it's
Oppenheim and Schaefer. Rabina and Schaefer did the one on LPC coding.
It's 6 dB per bit plus 1.76.
This is the original Bible.
Oh, hey, hang on. Yes, I've seen that.
I got this. I got Rabina and Schaefer's book on digital processing of speech signals, which is the title of that one.
Right.
It's blue from 1980 or whatever the edition is I have, because they developed the encoding needed to compress voice for POTS telephone systems from the 70s. So ISDN's been around a long time in digital voice.
So ISDN story. We were trying to rent out our condo in the Mays Landing area in New Jersey, and we're close to some IBM labs and the FAA and some other things. And one of the guys that was looking to move in there, he's like, well, I'm an engineer. And I'm, oh, what kind? You wouldn't have heard of it. And he said, he finally said, well, I did ISDN. And I'm like, you mean isosynchronous data network? He's like, how'd you know that? I can't remember what ISDN means now. But I'm like, really? You did wow. I mean, that's not the kind of thing you'd make up while talking to a civilian, you know?
It's easy to conflate too. Like, there's one thing I'm looking for here, but I can't seem to find the right term in the index, unfortunately. But the reason I was looking was we're talking about SNR, that calculator online's cool. But it's just one thing to watch out for. It's easy to conflate signal to noise ratio with dynamic range, because dynamic range, they are very closely related, but dynamic range is also super important for having a good number of bits. And that also applies to anything. So test equipment, 8 bits, you got hardly any dynamic range. There's always going to be a lot of analog front end in front of that to make the instrument measure what you want it to measure. That's why we have ×10 probes too, right? Or one of the reasons. Although the main reason for a ×10 probe is to not interfere with the circuit you're trying to measure.
The ×10 has higher impedance, right?
Yes, it's to be less invasive and lessen the probe effect.
So I just went to my bookshelf looking for my digital signal processing books, because I may have a version of yours. So I found Telecommunication System Engineering. This is where I learned what an Erlang was. I mean, it's just full of. If you're into telecom, this book is it. Then I found my RF microwave and millimeter wave from MACOM. I mean, this is back in the days of data books, right?
Oh, New Horizons. They don't
Yeah.
exist anymore.
No,
They
they
became
don't.
part of Avnet.
Yep.
And didn't Avnet just merge with someone else big recently?
Arrow
they
or somebody?
Merge with Arrow? I forgot.
RF circuit design. The green book used to be the brown book.
I have that. That is an excellent book. I highly recommend it.
I think
That one
brown
is
book-
super approachable.
And then here's an oldie. Hang on.
Anyway, can't find what I was
Oh,
looking
that's
for now.
not as old as I thought. I thought this was radio RF video applications, but I was thinking this is from the 80s. It's not. It's from the 90s. Always enjoy a trip to the bookcase. Then the books sit around my lab. They sit here in a pile till next show, and the book in the stack gets taller. So, got anything else you've been working on?
Oh,
Show your KiCad?
just repairing more tube amps as well this week, and a bunch of different things. Did it finish installing? It looked like it did. I got too many things open right now.
Okay, so Chris is mentioning. So I was an ISP from '95 to like 2010, and yes, we absolutely used ISDN PRI lines at my end of the connection. And there is no such thing as 56K. It's illegal at the phone company, but a USR decided it sounded faster than everybody else, when the maximum you can get on a POTS line is 53K by law, is my understanding.
Oh, I never knew that.
Yeah, the symbol rate.
ISDN, why did they make that law? Just to not compete with 64K ISDN?
Should I call it the law, or what the Bell standard is for? Oh, no, it's FCC. It's FCC subpart J. It's but
so it's only an American thing then, right?
Yes, and it's to be compatible with the switching equipment.
Okay. Yes,
yeah, somebody said 53.6. Yep.
Let me share my screen. It remembered it picked up settings from 6, which is good. That's a new thing, I think. And so I know that because it reopened the Pi Pico reference design, which I'd had.
So real quick, somebody just mentioned the compression on the lines that we used back then, the modem compressions. John Fagans, the guy that wrote the kernel for the VIC-20 and the Commodore 64, ended up working at and of course my career was based on his work because he did the C64 code. I wouldn't have had a career without him, in other words. Well, it turns out he went to work for USR Robotics and wrote like V42 biz and stuff. There's the compression and the error correction.
Oh, I remember trying to dial in all those settings when I was a kid, getting on the internet and not knowing what any of them were.
I had to support thousands of users. My company that I owned had to support, so I had to train all the technicians how to. So if you've interviewed with me, I would describe QAM to you. And then later I'd ask you questions about QAM to see if you soaked up any of it, because I didn't expect a technician to know what QAM was, but I wanted people that learned fast.
They had no qualms.
Yeah.
All right.
Right.
Well, it looks the same as 6.
The 53 qubit was to limit crosstalk, and that's exactly what I'm talking about, except it was in the form of energy and everything. But yeah, it effectively set the high end limit to 53K.
So they were lying to us when they said it was 56.
Absolutely
really
lying to you. Yep. And we'd get phone calls. Well, do you have 56K? No, ma'am. 56K doesn't click. So what? Got KiCad 7 open.
I'm trying to open the schematic on this, and on my other screen, I have this loading schematic dialog with the spinner, and I can't even pull it onto the screen to share it. It's weird. So that's not good. That's not a good sign. It should just open. Go to the view menu, PCB new.
Oh, he's talking to somebody else. I thought he was talking to you.
Yeah.
Well,
it's locked up. That's not a good sign, guys. It's locked up first thing.
Well, I learned something while that's spinning. I learned something from Altium today, and I had to use this week. I had to use the chat support. And what it was is I made the brand new project, and it came up with a sheet of paper around the PC board. And I hadn't seen that before.
Yeah, it used to do that all the time.
Config, and I looked for stuff, and I didn't see it. And sure enough,
it's buried in the properties panel.
Yep.
There is an object that's always there, and this is a legacy thing from ancient versions of Protel. So it goes all the way back to probably Protel 3, which was people used to run that on Windows 3.11. So that tells you. But the PCB editor always had this thing called a sheet, and it was a white background that was intended to represent the actual printout. If you were using a photo, or if you're using a pen plotter, it would represent an actual sheet.
Right.
So, and the board actually has a sheet size, and you can change it. But somewhere right around, I want to say it was right around Altium Designer 15 or so, they changed it so by default the sheet wasn't shown, so you wouldn't see it, because most people were like, I don't use that thing. No, I don't want to see it. Turn it off.
Yes. And this happened when I started a new project, just like any other time. Well, that's not true. I usually start projects by copying, because all my DRCs are already what I expect, and even the stack up. But it came in like this, and so I had to learn to do that by calling somebody, because
and that might be part of the template. They also
you're right. You're right. It probably was the template I chose, because I was confused with my own naming convention.
Because that was the other thing. They used to have tons of templates for they had templates for add-in ISA bus add-in cards and stuff. And years ago, they just removed all that from the build because it was taking up space and making. You know how some CAD tools, you're like, why does this, especially in electronics, I find, why does this installation need 4.7 gigabytes? It's outrageously large.
Right.
And to a lot of that was just content that came with it. So libraries, and I'm not saying it was 4.7. I don't think Altium ever got that big, but Ansys Electronics Desktop is around 4.7 gig. So it's not unique to one company. They all have a lot of stuff that it feels just like bloat. Right. But it's because these are big packages that do a lot for different situations. So they, but they had all those, and then they removed them from the build to make the builder lighter, smaller, less than 2 gigabytes, including libraries. And they're like, well, we'll make them available online. So they're still there. You can even download some of it. They put a lot of the more recent things were in the vault. What is now manufacturer part searched and focused only on components. So they kind of removed that. I guess they felt people weren't using them. But if you want to design your own PCIe card, like, you would have to pay thousands of dollars to get the PCI SIG standard from the
spec. Yeah.
Right. They're horrendously expensive. It's a barrier to entry.
So do you remember
or you could find a PCB design template that has all the pinout and the card shape and all that mechanical stuff, and the electrical connections are already done.
Right.
And so, like, you probably don't need to go by the standard. But that stuff is not visible anymore in Altium. Like, it should be, but it isn't. But you can still download it, I think, from the website. So yeah,
I used to use this a lot.
That's where you can download.
Right.
Yeah.
So for anybody that uses Altium and they're looking for the free components that you can use, Google Unified Components, and that'll get you a pretty reasonable library. It's not the newest. It's not.
They're kind of out of date, but
kind of out of date. They really
are. There's a lot of symbols and footprints, and if you have
connectors and stuff that don't go out of date,
even if you're not an Altium user, it's a good place to go if whatever tool you do use has some kind of means of importing it.
Yeah,
it's worth having a look there and downloading the content. Yeah, it can save you time.
Oh yeah, so my version of Altium down here in the lab does not have the EDA Snap EDA plugin, but I do in my office, where first I'll look in manufacturer panel, and then I'll go look at Snap EDA, because I'd say 9/10 of the components coming across Snap EDA meet my, don't have issues that I can tell.
That thing I mentioned right at the beginning of our stream, which I said I need to go back and look and see if it's still there. I just remembered the name of it, and I did a search, and it shows up on the legacy documentation site. It's called the Vault Acquisition Filters.
Ah.
I'm going to put that on the other screen so I can share it with you.
So Altium was the only company I ever knew that told me the reason I should upgrade was because they are rewriting the code in C++.
Yeah, they're still working on that. That's going to take forever. So acquisition. Oh, you just removed that again from.
No, I didn't do that.
Oh, no, I hit the wrong button. I'm sorry. I wanted to hide that little notification that says you're sharing the screen because it gets in the way. Yeah, acquisition filter. So basically, when you, this is the old user interface, right? But when you have your own, now it would be called Altium 365, but you used to be able to have this thing that was actually free called the Satellite Vault server that could run on your own network, and you could manage all your components in it. It was great. It was missing a few features, but it was really awesome. But you could connect to Altium's one in the cloud and download parts from theirs to yours. You can still do that and put them in your own A365 workspace. But they had this feature called acquisition filters, and you would put these in your vault, and you would use these. They were XML files, and you could apply them so that anytime you brought something from the cloud into your own vault, it would automatically update the visual appearance of symbols, so the color scheme, all that sort of stuff.
Right.
If your components in your library had a different standard than Altium's default, right? But the really important one, and they just show by example changing color scheme for symbols, which is kind of stupid and ridiculous. You don't need that. Where it really matters is in the footprint. You want to be able to reassign objects to the layers. Right. You want to map them to the layers that you've pre-assigned as your standard, because every company or every designer is different there. And so, but you'd have to do it in these raw XML files. You could add custom filters, and it was really painful. So, because again, we built this, but hadn't built the user interface to create the filters. And so it never got used or known, other than that one video I made years ago. It would be cool if we still had that, because again, every time I acquire parts from manufacturer part search, right, I have to edit the footprints or tell it to use the footprints I already have that are matching.
Right.
And it just takes a whole lot of extra time. It's almost not faster than just making the part from scratch myself,
Yeah.
So
all right.
Anyway.
Cool. Well,
That's just my rant for the day.
And I got to tell you, I am not near as comfortable making components as you are. I like to start from a component, you know, and modify it, that kind of thing. I'm just not an expert in it, and you know, remembering the designator layer, things like that.
Yeah, well, just so much of it is just so basic. Like I always have these preset layers that I use for everything. Like it shouldn't be that hard to have the tool just automatically. Oh, we're importing this footprint. It has a 3D model attached.
Right. Throw that on 16.
Put the 3D model on the layer named top 3D body. Just automatically do it. Like it should just do it, right? I don't understand why it doesn't.
Oh, I got a rant for you. So when I was troubleshooting the I2C and I'm plugging it to my digital Discovery I2C protocol analyzer, you have to guess, just like you did in UARTs, you have to guess what clock frequency the host is using. I'm like, you really can't do an auto clock? It's a clocked protocol. I mean,
wow.
In my day, we didn't have clocks. Everything was asynchronous, you know, and we loved it. We loved it. But it's like, oh, come on, just guess at the bit cell time from the you know. So you sit there and go 400K, 100K, 1 meg, you know, and I had to keep restarting the software. It's like, oh.
There's so many little irritating things in this world that should be easy, that you would think someone had already automated, and they haven't yet. And it's like, well, maybe that's impetus. Like maybe I should do that, but it's like I haven't got time.
Well, I was going to say, at the end of the day, I can blame a lot of my unhappiness in life on programmers, and with a subset of that being GUIs. I'm from the days where if a programmer made a bad GUI, you'd take them out back and do them, you know?
Well, this is the first rule that companies like Autodesk have really embraced. I've got to hand it to them for this one thing.
Consistency in the GUI, they're pretty good.
Well, they've a long time ago started actually hiring dedicated UX professionals, right?
Right.
And those people aren't programmers. They're more of them are graphic designers.
They're ergometric people.
Now, some of them are kind of wacky and have ideas that would work perfectly well in a phone app for browsing, I don't know, browsing dresses or choosing what lunch to order, but don't work for engineering CAD software and the mindset of an engineer. However, having said that, it's like it's different when you're a startup and everyone has to wear every hat.
Right.
But usually it's a good idea to have dedicated UX, and that may also be the product manager. They can be one and the same thing. And basically design how the user should interact first.
Right. And you know, my business, we did a lot of e-business programming in the early days of the internet. So I had my SQL programmers, and they would do what we called the gray box design. You know, they would just show us working, and then I'd have my web designers turn it into a GUI, a consistent.
So I just saw this in the chat and wanted to answer this too, Patrick. What you need is germicidal UV lamps. You don't need to go get something that's called a dedicated UV EEPROM eraser and pay tons of money for it. Make one. You get a T8 fluorescent lamp fitting, and you go on Amazon and you buy germicidal G8 lamps that go in that fitting, and then you find a timer that the fitting will plug into, and you just set the timer for however many minutes. That's all you have to do. And don't look at it. Don't expose yourself to it. It is short wavelength UV, and it will, it is very bad for human health. So
I've been around them.
Put it in a black box
I can
or
recognize
something.
them. They have a pink tint around them. The shorter they are.
I'll tell you what, it will be very cheap, and you'll have new parts they'll work flawlessly, and they double as germicidal as well.
Right.
Like
They
the same lamps
sterilize
which
your-
are used, they're used in meat lockers for making sure that germs don't grow on meat in the cool room. So
Okay.
do that.
Yeah, why are they are they expensive? Because the germicidal stuff is low stock due to the pandemic or something?
It's funny. I bought like 8 germicidal G8 bulbs on Amazon as soon as the lockdown happened, and they were cheap. They were cheap as chips, and they should still be. A device that's a UV EEPROM eraser, like the one you're holding there,
Right.
will be seen as retro computing gold. I'm going to charge a lot for this on YouTube, on eBay. Sorry. And people will pay it because they don't know what a UV EEPROM eraser has actually got in it. It's just a germicidal UV lamp that fits in a regular fluorescent fitting normally, or it may be a special one that's got like an octal base, like a vacuum tube.
Right.
But talking about vacuum tubes, I want to just quickly give a shout out and say thank you so much to Dave Usagi Electric, who was on our show 2 streams ago. Go check it out.
Oh, did he send you some 6AU6s?
He sent me a bag full of 6AU6s. And I'm thrilled because these can be used for high gain guitar preamps. And I'm going to, because I know they are sharp cutoff, and they were particularly designed for RF and high frequency stuff as well. But there are circuits which these can be put to good effect for guitar preamps. And I'm going to, I've done a bunch of stuff in the past with triodes. They're easy to design with. You get the curves and you do your load line, and same as JFETs.
Right.
I've never designed something with pentodes. These are pentodes, and so it's going to force me to learn pentodes, and that's a good thing. Always good to learn.
That's funny because being a TV repairman, pentodes were my bread and butter. You know, the triodes and stuff were in the tuner, the RF stuff, but everything was, and then there was Siamese pentodes and stuff, which is cool because you can do math in them. You can demodulate the color signal by having 1 cathode and 2 sets of grids.
Oh, those, yes. Those were especially made for TV.
Yeah.
And, these ones, were used a lot in TV, but I've seen various other circuits. Even Sony had tape recorders, audio tape recorders that had these in them for the microphone preamp. My
dad had a woolen sack to reel to reel, and you had to wait a minute for it to warm up before it would work. It was all tube. It was amazing back then. And this is
I would so love one of those. If I have a friend who's in the junk removal business, and I told him, I started showing him photos. I'm like, dude,
look for this.
anything that looks like old school electronics, don't junk it until you've sent me a photo. And like even that week, he found like a 1940s turntable, and I'm like, definitely that's worth something. You can either sell it on eBay or give it to me. But don't junk it. So anyway,
cool.
Yeah.
Well,
so
it's coming up on 10 after the hour here.
Wow. Yeah. I got more amps to repair. That could be another thing we talk about down the line if people are interested.
Well, you can show your curve tracer down the next time.
That's coming up. We will have a special guest from the Netherlands, all the way from the Netherlands. Let me go back to the website really quick because it is open here on my desktop. It's Ronald or Ron. I spoke to a different Ron yesterday, so I'm going to make sure I'm talking about the right person here. Come on. Anyway, yes, go to DOS4ever.com with the number 4 in the middle. Many of you have probably been there. And he developed a really, really nice curve tracer called the Micro Tracer that's specifically for tubes, but I'm thinking I could possibly adapt it to do transistors and MOSFETs as well. We'll see. He did an upgraded version of it after many years of painstaking variations and prototyping. He came out with an update called the Micro Tracer 6. Yeah, it is Ronald, so I got it right. And Ronald has agreed to jump on the show with us down the road. So
Hang on. Whoops,
I actually
shared
ordered
the wrong screen. Go ahead.
I ordered one. I'm waiting for it's been shipped, so I'm just waiting. It'll probably arrive in a couple of weeks, and I can put it together, and then we can have a show where this curve tracer is special. It's better than any of the other open source or other projects for curve tracers I've found, because the Micro Tracer 6 will actually happily get up to close to 1,000 volts plate voltage. So I can test a much broader range of tubes, and that's really important for me now that I'm doing more with tubes as well. So, yeah, cool product.
Where do you go for your caps if you need high voltage caps, like for replacing or new builds?
You can get high voltage caps. They're used in a lot of different products still, even non-tube products.
Where do you get them from? I don't see a lot in DigiKey and whatnot. I figured they're in other.
There are specialized suppliers.
That's why I figured.
There are specialized suppliers for the music industry that have them.
Transformers? Do they have?
And transformers, like I mentioned, Hammond manufacture replacement transformers for a lot of common guitar amps.
Okay.
And they're not the only one. Companies like some of them are expensive. They're considered like an upgrade, so they charge more for them. But there's different companies, and even the amp manufacturers themselves have been using the same transformer design for decades. So Fender will use Fender will use the same. They'll still be making the same transformers on the same equipment they used 50 years ago.
Right.
Why change it if the demand is still there and people still want to buy those amps? Even if you modernize them and put a printed circuit board in instead of hand point-to-point wiring, they still need the same transformer for the output stage. So they keep making them, and you can buy the replacements through their distributors. So that's generally where that stuff comes from.
Right.
So, yeah.
So back in the day, Macintosh amplifiers, not the Apple product, was known for its output transformer. And I liken it to on a Harley Davidson, the title travels with the engine, with the motor. Whereas on a Honda, the title transfers with the frame, right? So it's like the important part in a Harley. Well, to me, the Macintosh, the title transfers with the output transformer. And
okay.
They have little taps just for feedback, for linearity, and all kinds. It's an engineering marvel.
That some guitar amps do that as well, but even though that was more of a hi-fi thing, because
it was a hi-fi thing, but I remember having 12 and 14 taps off the transformer. They were intense.
Yeah.
So cool.
Yeah.
All right. Well, we'll hopefully see everybody here. Oh, I don't want to say next week, but next time. How's that?
Yeah, we don't know exactly when. It may depend on our guest or other guests. We do have guests.
If you want to be a guest, give us a shout.
Yeah.
Just remember that it's Fridays that we do this.
Right. So. Cool. We may also down the road. There are some guests I'm nagging to get on the show who are in Australia.
Yeah.
But time zone wise, this time does not work for them. So that would probably be a special broadcast or a pre-recorded. I guess we'd do it live, but we'd do it at a different time. So
I would have loved to have had him on the VCF thing. I mean, for Dave Jones, we would have set up a screen and had him part of the streamers roundtable. But we didn't even ask, knowing that it's like 2 a.m. there or something, that we weren't comfortable.
Yeah, he did verbally more than once agree to jump on the show with us. It's just timing wise hasn't worked out. So we'll see. Right. But I was hoping to get Steve Howe. Steve, if you watch this, I'm nagging you live right now. you would be a great guest, and these people would love to hear your stories about Apple Logic. And you've done some really amazing stuff, and you're a legend PCB designer. Dave Warren, one of the co-founders of Altium, used to say Steve Howell is the best electronics hardware designer in all of Australia.
Okay.
Dave Jones may disagree with that, but they're both legends, and I got to work with them both, and we have a lot of cool stories, and they're interesting and very educational people. So, anyway, just throwing it out there.
Yep. Very cool.
Cool. Thanks,
All
Bill.
right. We'll see everybody next time, and everybody have a good and a safe weekend.
Yes. And for those in the States, happy President's Day. If you get to take Monday off, I'll be working because I'm self-employed.
Right. Any day off is lost money. Yep. So, all right.
Cool.
Well, take care.
Good to see you all. See you. Thanks, Bill.